Now we will discuss principle of gas chromatography. So we'll see how it works. Gas chromatography works on the same principle like column chromatography. Sample is injected into the gas stream, which transports the sample in the column where separation occurs. As components of a mixture, they react with stationary phase of the column. Standard sample is also used to make a standard curve. So we have a pure sample and we make standard curve out of this pure sample, and then standard peak, retention time and area of the unknown sample is compared with the pure sample, and by comparison we are able to see how much of that particular substance or sample that has various components. And adsorption and solubility of a sample is manipulated by choosing the suitable stationary and mobile phase. So we can use different types of stationary phases, we can use different types of mobile phase by which we can manipulate the adsorption and interaction of various components of a mixture with the stationary and with the mobile phase, and accordingly separation of that particular mixture is affected. Here we can see various components of gas chromatograph. On the left side we can see this carrier gas, which is normally an inert gas like helium, argon, some other gas. There is flow controller, which can control the flow of this gas. On the top we can see sample injector, where the sample is injected with the help of some syringe normally. Then we have coiled this column, and this column which is coiled here so that it can be fitted into this space. This column has stationary phase. As the sample moves with the carrier gas through this column, various components of a mixture, they react with the stationary phase which is present in the column, and then they separate, they come out of this column, and detector on the right side detects various components of a mixture according to their retention time, and this detector then sends those information to the attached computer or to the attached software, which is able to record or analyze various components, and the waste products, they are also collected along with this instrument. Differential affinities of the sample components with the stationary and mobile phases, they results in their differential separation. Higher the adsorption with the stationary phase, the slower the molecule will move through the column. जाहिर है जिसकी इंटरेक्शन ज़्यादा होगी वो ज़्यादा देर तक कॉलम के अंदर रिएक्ट स्टे करेगा और अकॉर्डिंगली उसकी एल्यूशन स्लो होगी, और जिस कंपोनेंट की इंटरेक्शन कम होगी, चूंकि उसका रिएक्शन इंटरेक्शन कम है, तो वो फास्टली कॉलम में से एल्यूट होके बाहर निकल आएगा. Higher the solubility in the mobile phase, the faster the molecule will move to the column, and of course it will have more elution rate. And detector which is used with the instrument that is used to quantify the components of the sample as they elute from the column. तो और हमने पहले ये डिस्कस कर लिया है कि जैसे जैसे किसी मिक्सचर के कंपोनेंट आते हैं अपने रिटेंशन टाइम के मुताबिक, उसी तरह उनको डिटेक्ट किया जाता है और उनके मुतालिक जो पीक्स होती हैं उनको हम स्टैंडर्ड कर्व के साथ कंपेयर करके उन पीक्स की जो नेचर होती है वो डिटरमिन कर सकते हैं.